Okay, so this is going to finish up 1.5. It's going to finish up 1.5. So this is one of the completing the square problems. But it's a little bit difficult because we have a value, so a number other than 1 in front of the w squared. First thing I need to do is to move c, move your constant, so subtract 4 from both sides. Okay, I need to divide everything by 3, so I need to factor out the 3, not 3w because it has to stay quadratic, so you have to keep the w squared. Since 3 does not go into 8, remember I just have to write it as 8 over 3. 8 over 3. That's what factoring out means, is to divide. Okay. Now divide everything by 3, so divide both sides by 3. Now I'm ready for the completing the square step. So I have to figure out the number I need to add to both sides. So that little formula was b over 2 squared. But I'm going to have to write it as 1/2. So instead of dividing by 2, I'm going to multiply by 1/2 because b is already a fraction. Or b is already a fraction, so I didn't want to have 8 over 3 over 2. So I'm going to have 1/2 times negative 8 over 3. Okay, so that would be negative 8 over 6, which reduces to negative 4/3 squared. Okay, when you square a negative, it's positive. 4 squared is 16. 3 squared is 9. So I'm adding 16 over 9 to both sides. Okay. So I set this up so it would factor to this binomial squared. So what does it factor to? W minus 4/3. This number here, right before you square. Yes?
How did you get 4/3?
Over 6. And then you reduce. Yeah. Okay. So you need to add then negative 4/3 plus 16 over 9. So negative 4/3 plus 16 over 9. And you can use your calculator to help you. But that should be 4 over 9. Is that what you guys got?
Yeah.
Okay. 4 over 9. Now we're at the solving step. So we completed the square. Now we solve. So square root both sides. How did I get what? I combined these like terms. Negative 4/3 plus 16 over 9. So that went here. Okay. So I get w minus 4/3 equals plus or minus. So remember when you square root a fraction, you square root top, square root bottom. Both of those will simplify. So square root of 4 is 2. Square root of 9 is 3. Okay, add 4/3 like terms, so go ahead and find your two answers. They're not like terms because they have a common denominator. They're like terms because they're both rational numbers. There's no radical or anything there. I mean, it's great they have a common denominator, but that's not what makes them like terms. All right, so 4/3 plus 2/3 would be 6/3, so that is 2. 4/3 minus 2/3 would be 2/3. Okay? Yep. Exact answers. No decimals. An approximate answer here, and you wouldn't even need to do this, but the approximate answer here would be like 2 comma, and then if you rounded 2/3, so like 0.67. Yeah, so if you're doing technically then, if you're doing approximate answers, it is exactly 2, so you never have to put the approximate. You would say equals 2 and then approximately 0.67. Yeah. I'm not going to be that technical, but that would be the correct way. Okay, but we're good with the exact answer. Okay. All right, so now we're going to talk about the quadratic formula, and I wanted to show you how we get the quadratic formula, but I don't know if we have time. I'll try to go through it quickly. It's not one of those things you have to memorize for a test or anything, but I think it's interesting to see, at least to some of you, how we get it. So quadratic formula is something you have to memorize. So it's x equals, okay, good, opposite of b, plus or minus the square root, b squared, minus 4ac, all over 2a. So maybe you learned a little song or something to help you memorize that. You need to know it. So whatever you need to do to memorize it. Okay? All right, well, that formula comes from completing the square. So I'm going to show you how we get that formula. You do not have to write this down. You do not have to memorize this. So here's our quadratic equation, and basically what I'm trying to do is solve for x. So I want to solve for x so I can, find solutions no matter what a, b, and c are. Okay, so I'm going to complete the square. First step in completing the square, move your constant. So subtract c. Second step would be to factor out your a. You don't want the a there. And since I don't know if a goes into b, I just have to write that as b over a x. Divide both sides by a. We had to divide by a here, same reason why we had to write this as 8 over 3.
No, I know.
Okay.
What does this do?
Okay, what I'm trying to do, I'm solving for x. I'm solving for x, and when I solve for x, we get the quadratic formula. So what I'm showing you is where the quadratic formula comes from. Okay? That's okay. You guys don't have to write this down or have to memorize this. It's just FYI. This is like an algebraic proof of the quadratic formula. All right, so I need to complete the square now. going to use the 1/2 b squared. Okay, so that's b over 2a squared, which is b squared over 4a squared. So when you divide or multiply, you distribute your exponent. So b squared over 4a squared. Okay. So then this will factor to x plus, right here, the number before you square it, b over 2a squared. And then this is here. So I'm going to be able to combine these. So in order to combine fractions, you have to have a common denominator. So I need to multiply this one by 4a over 4a. So you might start to see it come together here. So that's negative 4ac all over 4a squared. Okay, so there's our minus 4ac there. I can now add the numerator. So I'm going to write that as b squared minus 4ac. Okay. Square root both sides. Okay, plus or minus b squared minus 4ac. The square root of 4a squared is 2a. Okay, and then subtract okay. They're a common denominator, so you can put them together. So negative b plus or minus b squared minus 4ac all over 2a. Voila. That is the quadratic formula. So quadratic formula and completing the square do the same thing. They solve quadratic equations whether or not you can factor. So you really wouldn't want to use either one if you can factor. But if you can't factor, then either way will work. On the test, it will be specific. There is a question that says solve by completing the square. So you have to complete the square on that one. It's the one on the test is not quite as hard as this one, but it's a little bit harder than the one you did on the one. Okay, so somewhere in the middle there. Okay, so questions about that? All right, so let's actually use it. Okay, we want to use the quadratic formula to solve this problem. Whenever you're doing quadratic formula, plugging in fractions can be tedious and can be easy to make mistakes. So what we want to do first is let's get rid of the fractions. Now you don't have to do this, you don't have to get rid of the fractions, but it will make your math easier when you plug it in. So to get rid of fractions, I multiply by what? Right, so I multiply by the LCD, which is 21. So I'm going to multiply both sides by 21, which means I have to distribute here on the left. Okay, so 21 times 2 7s. Nothing special here. You can just type that in your calculator. You should get 6. Okay, 6p squared. Because because what I'm doing is I would cancel and have a 3 left here, so 3 times 2. And then 21 times negative 3, negative 63. And then 21 times 8 over 21, 8. Okay, when you do quadratic formula, you need it equal to 0. So subtract your 8p, and let's put it in the middle where the b goes, okay? So 6p squared minus 8p minus 63 equals 0. Because you'd subtract 8p from both sides. Okay, so A is, okay, 6. B is negative 8. And C is negative 63. All right. Write the quadratic formula. The more you write it, the easier it is to memorize. So x equals opposite of b plus or minus square root of b squared minus 4ac all over 2a. So this isn't x, this is p. I mean, obviously, if you write x equals, I'm not going to count off, but our variable is p, so p equals opposite of b. So what would I write? Plus or minus square root of negative 8 squared, which, yes, is positive 64. You have to put that negative 8 in parentheses. Minus 4 times negative 63, good, all over 2 times 6. Okay, when you calculate this, calculate just what's under the radical first. That's called the discriminant. We're going to look at that in just a minute. So just what's underneath, not including the radical, because if you put the square root, you get a decimal, you don't know what the exact answer is. So you should type all that in, and we get 1,576. That's what you guys got, but you should get. Okay, all over 2 times 6, which is 12. I'm going to save you a little bit of time. This does simplify, but just by 4. 4 goes into that, and it goes into it 394. Yeah, okay, so it'll be 2 square root of 394 over 12. Okay, now I could see that if I factor out a 2, 2 and this 12 could reduce. So I'm going to go ahead and do that. Okay, so then that gives me a 6 on the bottom. And we're good. We can leave it like this. Right. You could separate if you wanted. You could write it as 8 over 12 plus or minus like this. And then make this one 3/4 and this one 394 over 6. You could do that as well. Either way. So I just want it reduced in some way, if you can. Now, if this had been a 13, which it wouldn't ever because you multiply by 2, but just say, if this had been a 13, you would not have factored, so if that had been 13, you would not have factored out a 2 because the 2 wouldn't cancel with 13. All right, so you would only do that if you know it's going to somehow reduce in your denominator. Yes?
So we still can factor out even if it's 4 or 16.
Right, so you cannot do this because that would give you a 3, but that's not technically, this is not over 3 as well. That would be still over 6. Yeah, I'm sorry, you're right. That should be 2/3. Not 3/4, 2/3. Yeah, thank you. Okay? Questions about that? I don't care. Either way. I just want you to reduce it if possible in some way. So you could either do it, so from here you can do it like this or like this. Okay? Alright, so we're going to back up and talk about the discriminant now. The discriminant is a special part of the quadratic formula. It's just b squared minus 4ac. It's just that number under the radical. And that tells you specific information about your solutions without actually finding the solutions. So it helps you count the number of real and complex solutions that there will be. So b squared minus 4ac, remember, is the part under the radical. So we're just looking at this part here. And it tells you the number of real and complex solutions. So here's the chart here. So for quadratic, ax squared plus bx plus c equals 0, then you have three options. If b squared minus 4ac equals 0, so if what you get under the radical is 0, then you just get one solution. Solutions, roots, those are the same thing. Those mean the same thing. Okay, solution, roots, those are the same thing. So if it equals 0, the equation has one real root. When you factor, it will look like a repeated number. So, like this, where you would get x equals -2 and x equals -2. You would have the same number twice, so there's only one solution. If b squared minus 4ac is greater than 0, the equation has two real roots. So you take the square root of a positive number, you get two real numbers. It could be irrational, like the one we just did where there's a radical, but it's still a real number. If it's less than 0, so if you take the square root of a negative number, then you get two complex numbers. You'll have I. They will be imaginary. Okay. I want to do an example before you go, so I'll come back to this page at the end if you didn't get everything written down yet. Okay, so it can also tell me if it's factorable, so without actually factoring it. We're going to do b squared minus 4ac, so that's -5 squared minus 4 times 2 times -3. I type all that in and I get 49. So it is factorable because 49 is a perfect square. So it's positive also. Since it's positive, I know I have two real roots. And since it's factorable, it'll also be rational roots. If it's not factorable, it's irrational. And then we'll stop there. Okay? Work day tomorrow. Bring your books.
Oh, okay, that's the one. Here, okay.